Hello. So first part of our question is the intensity of a progressive wave is defined as the average power transmitted through a surface per unit area. So that means intensity I is basically power per unit area, and power is basically energy per unit time upon area. So first we have to define the base units for energy. Energy is defined as F into D, means force into displacement. The units of force is defined usually from Newton's second law, which is mass into acceleration. So kilogram meter S minus 2, and displacement will have units of length. So it is V kilogram meter square S minus 2. Now if we put here, so I will be equal to energy per time, and per energy per unit time, so it will be kilogram meter square S minus 2 per unit time, so S minus 1. And A is the area, which are units of meter square. So meter square, you cancel out, it will be kilogram S minus 3. So it is the units of kilogram S minus 3 it's written here. Okay, so the first part is completed. In the second part B, first one is the intensity I of a sound wave is related to the amplitude x naught of the wave by I equal to k rho c f square x naught whole square, where rho is the density of the medium through which the sound is passing. So basically rho is the density of the medium. C is the speed of the sound wave. So basically units of speed. F is the frequency of the sound wave. K is a constant. Show that K has no units. So what we will do, we'll first calculate the total base units for this rho c f square x naught square, where rho is defined as the density. So we say mass per unit volume. So mass have units of kilogram and volume meter cube, so kilogram minus 3. C is the basically speed, so meter S minus 1. F is basically frequency, so it's per second, means hertz or per second. So F is basically units of S minus 1. And x naught is basically it has amplitude, so it will have unit of m, meter or length, you can say, right? So the multiplication of whole term will be, so basically if we have to define the units of K, so K will be like I upon rho C F square x naught square. Okay, so I have units of kilogram S minus 3, and rho have units of kilogram M minus 3, C have M S minus 1, F square is S minus 2, and it is M square, right? Kilogram will cancel out. M minus 3 is here, you see, S minus 1, S minus 2, S minus 3. So this will cancel out with this. M minus 3, M into M square. So M is plus 2, plus 1, plus 3, minus 3, 0. So that means it will be 1. So the K is equal to 1. That means K has no units. So that's proved. In the second part, calculate the intensity in pico watt per meter square of a sound wave, where K is equal to 20, rho is equal to 1.2, C is equal to 330, F is equal to 260, and X naught is equal to 0.24 nanometer. Okay, so you focus here, 0.24 nanometer. So nano is basically 10 to the power minus 9. So it will be 0.24 into 10 to the power minus 9 meter. Okay, so here we will calculate the intensity I equal to, if we put the values, 20 into 1.2 kilogram meter cube into 330 into, sorry, 330 here in units is meter per second, so meter S minus 1 into F square. So F value is 260 second inverse square, okay, into x naught square. So it is basically 0.24 into 10 to the power minus 9 meter square. So basically it will become 20 into 1.2 into 330 into 260 square into 0.24 square into 10 to the power minus 18, okay, into, and units you will know because as we have calculated here, so basically kilogram only here, meter minus 3, meter minus 2, and meter 2 here. So that means meter will be cancelled out, S minus 3. Okay. So here, if we will calculate, use our calculator, because this is a long calculation. So we can use the calculator. So it will be 20 into 1.2 into 330 into 260 square into 0.24 into 0.24. So that is basically coming, the value of I, if I write here, it is 3.084 into 10 to power 1, 2, 3, 4, 5, 6, 7. Yeah, 10 to power 7 into 10 to power minus 18 kilogram centimeter cube minus 3. So that can be written as 3.084 into 10 to power minus 11 kilogram S minus 3. Okay. So here it is written, you have to give in pico watt. So pico is basically 10 to power minus 12 already. So if we write 10 to power minus 12 here, so basically we have to divide by 10 and multiply by the 10 at the same time. So it will be 30.84 into 10 to power minus 12 kilogram S minus 3. So it is now pico, 30.84 pico kilogram S minus 3. So now watt per meter square. So watt is the unit of power and A is the unit, area as a unit of meter square. So this is same as kilogram S minus 3. So that means our value will be 30.84 pico watt meter minus 2. Okay, because watt meter square is the same as kilogram S minus 3, because this P has the units of watt in general terms and A is the unit of meter square, meter to the power minus 2. So therefore our value is 30.84. Thank you.